Today we are going over Chapter 3, Problem 11. The radius r of a circle is increasing at a rate of 4 centimeters per minute. Find the rate of change of the area when r equals 34 centimeters.
So, for the first step of this, we have to draw a picture. So, step 1. Is to sketch. So we're going to read the question all over again, and they tell us that it is a circle, so we're going to draw a circle. So I drew my circle, and we already know that a circle has a diameter and a radius, so we're just going to draw this dot here and draw the line. Now we have to figure out what the radius is, and they tell us that the radius is 34 centimeters. So I'm going to take my beautiful purple marker and I'm going to say that r equals 34 centimeters. And I pretty much got it right here. Alright. We also know that, and I'm going to take a green marker to know this, that the radius of our circle is increasing at a rate of 4 centimeters per minute. So I'm going to highlight that. 4 centimeters per minute. So I'm going to write that here, increasing at a rate of 4 cm per minute. So it's centimeters per minute. And now, since we have our beautiful sketch drawn out, what we're going to do next is determine our equation and our variables. So step 2. Okay, so we know we are looking for the area, so I'm going to put that in brown because that's what we are looking for. Oh, that's the equation that we'll be using. So we have to know our area formula. So our area formula is A equals pi r squared. Simple, you remember it from algebra. So now we're going to look at all our variables and determine what all our variables are. So we know that our radius is 34 centimeters. Radius, which is r, equals 34 centimeters. Okay. And we know in green we had highlighted centimeters per minute is 4, so it says increasing at a rate of 4 centimeters per minute. So we know it's got something to do with 4 centimeters per minute. And when they say at a rate, so rate is r, or radius is r, and the time is t, and rate is dr dt. So this is how we get the rate. So that's what it's saying is that the radius is increasing at a rate per time. Now, we are looking for the rate of change in our area, so I'm going to put it in black, and I'm going to say we are looking for dA dt, because this is the question we have to solve. Now, step 3, it's a little bit difficult, but it's not that bad. So, step 3. Is to take the derivative of our equation. So I'm going to take my brown marker and I'm going to write our equation down. So our equation, which is not copying from right here, is A equals pi r squared. I'm going to take the derivative of both sides. So I'm going to times that by d dt on one side and by d dt on the other side. So we're going to say that this is dA dt, and then we're going to keep this the same because it's a constant pretty much. And we have our pi here, and we're going to take the derivative of r, which is 2r dr dt. So next is not a bad step, it's my favorite step. to be honest. This step is really easy. We like to call it the plug and chug. So step 4. Alright, so with this one, we just basically take the information here and we plug these into there and we chug it to solve the information. So what I'm going to do is I'm going to figure out what we're looking for. So we have said we are looking for dAdt. So we are looking for the rate of change in the area per time. So that's what we have written in black here. So I'm going to nicely take this black marker and I'm going to circle that because that's what we're looking for. So this is what I'm writing in black, dAdt. Now, we need to determine what's staying the same and what is changing. So it looks like we have an R in the dRdt, and we also have this here, so we're going to plug these into there. So what is staying the same is our 2 pi. So I'm going to say pi times 2, which is staying the same. Then I'm going to plug in my R, which I have written here in purple. So I'm going to circle it in purple so I know what it is. And that is 34 centimeters. And I have my dRdt, which I have here in green, so I'm going to square this in green so I know what this is when I write it down, and that is 4 centimeters per minute. Alright, so here's the easier part. You just chug it, which is basically multiplying to solve my answer. So I'm going to take my dAdt, and I'm going to keep that the same. I'm going to keep my pi the same because it really will never change. And what I'm doing is I'm going to multiply the 2 easiest things to multiply together. And I say it's the 2 and the 4. So I'm going to multiply those together and I'm going to keep 34 the same. So I'm just going to write it down again. And it's 34 centimeters. I will be multiplying 2 and 4. So that will be 8 centimeters per minute. Next, I will just be solving. So now I'll just times my 34 and my 8 together. And so I will copy this down one more time. My dAdt equals 34 times 8 is 296. So I'm going to say 296. And I have the centimeter times the centimeter. So I'm going to have centimeters, pi. Can't forget my pi, which is right here. And I'm going to have centimeters squared per minute. And this is my final answer. Thanks, you guys.